This video is about solving quadratic equations by factoring.
Okay, so the instructions here say to solve each equation by factoring and using the zero product property. If you look at the equations, you should recognize that they're quadratic, similar to the expressions that we've been factoring, except for that there's an equal sign in there someplace. So in the first example, it says equals 0. That's how you want your setup to be before you jump in and try factoring anything. You want to make sure all of the variables are on the left side of the equation, and it says equals 0 on the right side of the equation, so that your quadratic expression is on the left, and you look for the factoring techniques that you can apply that we've been working on. So the first technique is to see if you can pull out a greatest common factor. And here that's a 3x, which will leave you with x in the first term minus 4 in the second term, and then it still says equals 0. So you've now written this as a product of two factors. 3x is the first factor, x minus 4 is the second factor. Whenever you have two factors multiplying together to equal 0, as it's written here, it stands to reason that one of those two factors must be 0, because how do you get 0 as the answer to a multiplication problem? For example, it would have to be 8 multiplied by what to give you 0? And of course the answer is 0. So in order to have a product equal 0, one of the factors or both of the factors must be 0. So that's the zero product property. It says that if you have a product and it equals 0, one of the two factors or both of the factors must equal 0. So we want to set both of our factors equal to 0. And these are linear equations that we can solve, right? So either 3x equals 0 or x minus 4 equals 0. And we solve these two linear equations using just the operations, adding, subtracting, multiplying, dividing. Here we divide both sides by 3, and x equals 0. Here we add 4, and x equals 4. So we actually have two possible answers for x in the original equation that could give 0. So if you plugged in both of these answers for x in the original equation, you'll see that they both work. So quadratic equations typically have two answers for what x could be. In the next example, it's very similar, except for that it doesn't start by saying equals 0. So you want to move the 5x over first, so it says equals 0. Now try to factor the left side. Now we bring it as a product of two factors. We set each factor equal to 0, because one of them or both of them must be 0. First one's already solved. The second one, we add 5 to both sides and get your two answers for x. Similar, only these are quadratic trinomials that we're factoring. So as soon as you recognize that you're in a quadratic trinomial, you want to write your two parentheses and try to figure out what the two binomials were that got multiplied together. So we split up our x and our x. We're looking for factors of 35 that add up to negative 12, which will be minus 7 and minus 5. And then we have our two factors equal to 0. So either this factor equals 0 or this factor equals 0. Solve by adding 7 to both sides, and x equals 7, or add 5 to both sides, and x equals 5. So those are the two solutions for this one. And in the second example, start by getting everything on the left. Make it say equals 0. I see that there's a greatest common factor that I can undistribute, which is a 3. And then I have a quadratic trinomial in here that I'm going to separate into its two binomial factors. So I split up the x squared into x and x, and I look for factors of positive 3 that add up to negative 4, which is only 3 and 1 are my choices, and they both have to be negative. Now when I solve, I have 3 factors being multiplied together to equal 0. However, this factor doesn't have an x with it. It's not going to lead me to one of the solutions. It is never going to equal 0 because it's the number 3. So we basically ignore it at this point. Or you can think about it as dividing both sides by 3 just to get rid of it, right? And now we have 0 divided by 3 on the right side of the equation, but that's just 0 anyway. So basically, the 3 didn't matter, but we needed to get rid of it in order to factor the rest of it. So these are the factors that we have to solve, the factors with x in them, and this one would equal 3, and this one would equal 1. So if you ever factor out just a constant, a number, it doesn't lead you to one of the solutions. You can just ignore it. Here we've got two of the special types. So when you get this to say equals 0, you may recognize that you have a perfect square trinomial. because the factors of 36 that add up to negative 12 would be negative 6 and negative 6, which means that there actually is only one solution to this equation because each of these factors leads you to the same answer, and you only need to write it once. In this one, it doesn't look like something I can factor because I don't see that I have any perfect squares, but I can take out a 3, and then maybe I'll recognize the difference of perfect squares. And the difference of squares was a factoring technique that we learned because the middle term is 0x, or the middle term canceled out, because you ended up with the same thing in both parentheses, but 1 minus and 1 plus. So 2x and 2x is how we split up the 4x squared. Plus 3 and minus 3 is how we split up the 9. Again, the 3 does not lead me to one of the answers, so I ignore it. And then I have to solve each of these factors, and I'll show the work for them. This one I have to subtract 3, so 2x equals negative 3, and then divide by 2. So negative 3 over 2 is one of the solutions. In this one I have to add 3, and then divide by 2. So x equals 3 over 2 is the other solution. And then it gets much more complicated. We didn't go over this in our factoring lesson because I was saving it for here. You're asked to use factoring here to solve it, but it doesn't follow any of the factoring rules that we've practiced so far. There's nothing I can factor out from all 3 terms. I don't see any perfect squares, so it's not one of the perfect square trinomials. And I haven't practiced doing this kind of quadratic trinomial. So that's what we're going to do here for the first time by simply guessing and checking what the numbers are going to be in our 2 binomial expressions. So it's still a quadratic trinomial. But now, instead of just splitting x squared into x and x, I have to deal with this 3x squared, which of course is different, a little different. In order to get 3x squared in the first term, I must have multiplied, and if you think about it, there's only really one way to get a 3x squared. I must have multiplied a 3x times an x. There's no other way to get 3x squared. There's no other way to factor 3x squared. Again, I skip over the middle term, and now I'm looking to that negative 7. Because I know whatever I fill in here and here, in the green spot that I just underlined, it has to multiply to make negative 7. But this time I cannot think of things that add up to 20x, because it doesn't work that way when there's a number in front of your x squared. So this time I want to figure out all my possible combinations that would multiply to negative 7, and use guess and check to determine which one is correct. If you think about the things that make negative 7, of course, it's 7 and 1. But one of them would have to be negative. Either the 1 is negative or the 7 is negative. I'm setting up 4 different versions of this because there are 4 different possibilities for where I could fill in the 7 and the 1. For example, I could have the 7 be positive and the 1 be negative, with the positive 7 in here and the negative 1 in there. Or I could have the 1 be this positive 7 and the negative 1, but switched in different parentheses. So I can put the negative 1 here and the positive 7 here. And these are very different problems. If you FOIL together the first one, you'll get a very different answer from when you FOIL together the second one. There are 2 more possibilities. That would be if the 7 was negative and the 1 was positive, or the reverse version of that, where I put the plus 1 here and the minus 7 there. These are all of the possibilities for factoring this expression. So that's sort of the guess part of guess and check. And now I have to check them to figure out which one actually gives me the original expression. If you FOIL this together, you get your 3x squared, then you get a minus 3x, a plus 7x, and a minus 7. First term came out the way I wanted to. Last term came out the way I wanted it to. But the middle 2 terms do not add up to the 20x that I was looking for. So this one I'm going to throw away. That's not the correct factoring. Second one, I get 3x times x is 3x squared. 3x times 7 is plus 21x. Negative 1 times x is minus x. And then negative 1 times 7. If you get these 2 middle terms added together, you'll see it's 21x minus x. And that does equal positive 20x. That means this is the one. This is the correctly factored version of it. So now I can erase all of the other ones on the screen, or if you don't write them down, erase them from your head, because we don't need to check the other ones. We found the one that worked. I erased the first one because it didn't work at all. And I don't need to keep that FOIL version. I just use that to check it. So up above, I'm going to rewrite the correct answer. It was 3x minus 1, and it was x plus 7. It equals 0. And now I use these two factors to solve the equation. 3x minus 1 equals 0, x plus 7 equals 0. Add 1 to both sides, divide by 3. There's one answer. And this one is just subtract 7. So there's the other answer. So guess and check factoring is not so bad. When do you have to do it? You have to do it when there's a number in front of your x squared that you cannot factor out from all the terms. And the only way to figure out that plus 20x is to practice FOIL, 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 FOIL till you find the one that adds up to positive 20. Factoring by grouping is another method that we didn't talk about in our first factoring lesson. This is when you have 4 terms in a row. And of course, your instinct when you look at this might be to combine the 2 middle terms. But I want you to practice doing it a different way because it's leading up to something in the final slide. So in this case, we have 4 terms in a row. And there's no greatest common factor that you can take out from all of the terms. But if you group together, and that's why this is called factor by grouping, if you group together just the first 2 terms, and then separately create another group for the final 2 terms, you can factor each of these separately by taking out a GCF. So I can take out a greatest common factor from my first 2 terms, which is 3x, which leaves me with x plus 2. And then I can take out a greatest common factor from my next 2 terms. Remember, if the first one is negative, as this is, you're expected to take out a negative. And of course, they're both divisible by 7, which will leave us with an x and a positive 2. Now you'll see in both of these terms, so this is one term and this is another term. In both of these terms, there's an x plus 2, right? The parentheses came out the same. So you're going to take that x plus 2 out, and you're going to put it in front of this expression. Just put it there one time. It's like you're factoring out the whole parentheses. And if you factor out the parentheses from here, you're left with just 3x. And if you factor out the parentheses from here, you're left with just minus 7. And now you've factored it. It looks like 2 binomials being multiplied together. And you can solve it using the zero product property, right? Set each factor equal to 0. If you had combined the like terms in the beginning, it would have been a little bit more work for you to try to figure out the 2 factors. So sometimes factoring by grouping is your friend. When you've got 4 terms in a row, you should always try factoring by grouping first. Which leads me to this final example. Splitting the middle term factoring is another method so you don't have to use guess and check. So if we go back a couple slides, you'll remember on here we had to come up with 4 possibilities for making negative 7. FOIL, 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 so we figured out that it would not work. There's another method that will work every single time so you don't need to guess and check. And that's called splitting the middle term factoring. So here I have a 5 in front of my x squared and a 6 in the constant term. And there's just too many combinations that could make 6. Now, I don't feel like using guess and check is going to be very efficient. Because it could be a plus 3, a plus 2, or a plus 6, a plus 1, or a minus 3 and a minus 2. So there are just too many options. I'm going to use splitting the middle term factoring instead. And here's how this method works. You start by multiplying the first coefficient by the constant term, 5 times 6, and that's 30. I always write that number above the middle term, because now, instead of looking for factors that make 6, I want to look for factors of 30. And I want to pick factors of 30 that add up to the middle term, so adding up to negative 17x. The factors I pick are 15 and 2, because I know 15 times 2 is 30. And because I need them to add up to negative 17, they both need to be negative. With the 15 and the 2 that I just picked, the negative 15 and the negative 2, you do not fill in 15, fill in 2, and be done with it, right? This is a common mistake in applying this method. Instead, you use the 15 and the 2 to split the middle term, which is the name of this method, into the 2 like terms that must have been there before they got combined. So we've split negative 17x into negative 15x and negative 2x. We bring down the first term and the last term, and now we have 4 terms in a row that we can factor by grouping, the way I just demonstrated on the slide before it. So if you look at just the first 2 terms, you can factor out a 5x, leaving you with x minus 3. If you look at just the second two terms, you can factor out the negative 2, leaving you with x minus 3. Both terms have an x minus 3, so you take it out. When you take it out of here, you're left with 5x. When you take it out of here, you're left with the minus 2. And this is the magic combination that adds up to the negative 17 in the middle, and you didn't have to use guess and check. You can go straight to the solutions. So splitting the middle term is by far more consistent, easier than guess and check, almost all the time. All you have to do is practice this method where you're doing a times c, which is the first term times the last term, pick your two numbers, and then split that middle term. Factor by grouping, and you can get the result without having to use guess and check and be 100% confident that that's the combination that works. And that is all.